friends, you are watching ERUDIRE Plus, the professional CAD/CAM solution provider. This channel provides basics of finite element analysis and computer-aided mechanical engineering design and analysis using CAD-related software. Let's get started.
Hello friends, today I'll show assembly of a plate type heat exchanger using SolidWorks. The analysis of this plate type heat exchanger has already been explained in another video. This is being done with the request of some of my subscribers. For better understanding of the model, we can explain the assembly and the individual parts separately. Okay, so the plate type heat exchanger is mainly consisting of 4 different parts. The most important part is this one. This is the main plate, right? Some kind of herringbone pattern we have provided to make a turbulent flow inside this one, right? For making this model, what we have done with 3D sketch, we have made some inclined lines and then we have used swept cut for getting this impression on the plate, and then the pattern of this one has been maintained along this direction, and finally with respect to the central axis we have made a mirror of this whole pattern in the left side. Similarly, we have done the same thing in the opposite side also. In opposite side you can see the pattern is different, right? And these are the actually passage of water or fluid. The top one you can see this is hot water inlet and this is hot water outlet. Similarly here also this is the cold water inlet and this is cold water exit. This is the most important part of the plate heat exchanger. This is known as main plate. Excluding this one also we are having some other parts, like we'll show it right now. Gasket. This is the gasket. Actually this gasket we are using two ways. We are using this one by reversing the side. One time we are using as a front gasket and in the next time we are using as a back gasket by reversing the direction. Okay, this is made up of high quality rubber. Okay, well, let's see another part of this one. Let's open it. We're having two more parts. This is end gasket and front gasket. Let's see. This is the front gasket actually. So here in this space fluid will be trapped. This is also made up of high quality rubber. Now another part is remaining. Let's take that one. End gasket is remaining. This is the end gasket. Again this one will be at the end of the plates, and at this location some fluid will be trapped, right? These are the different parts. We are having actually 4 different parts. Actually this front gasket and end gasket is having very little difference. The end gasket doesn't have any kind of like holes for passage of fluid particles, and in the front gasket we are having some holes for the entry and exit of fluid particles. Okay, these are the thing. Now we'll start assembly of these different parts. We'll start assembly. So starting assembly, we've taken all the parts. First one will be the end gasket. This one will be fixed. This is the front gasket. This is the main gasket, and we are having one important part, that is the main plate. This is made up of actually copper, and all others are made up of this high quality rubber, right? So you can do one thing, like this part all are made up of rubber, high quality rubber. We can change the color of this one. Appearance will be rubber and matte rubber it is, right? So we're converting this one as matte rubber. Done. These are the parts, right? Here in this case only the first part, that is the end plate, that will be fixed, and all others can be moved, right? So we're starting our assembly. As we have told that this is the end plate, this will be fixed. Now next to that one we have to attach the main plate, right? Starting from met, and here this hole should be met with the location of hole here at this location. Okay, this is done. So for this assembly we have to consider 3 different constraints. Only first constraint is done. We have to consider 2 more constraints. Now next constraint is these two edges should be parallel. So select this one and that one, these two are parallel, green check. Now the distance between these two edges should be 0, so we can make it right now. Select this edge and this edge coinciding, green check. So all the three constraints are met, this assembly is done, right? Okay, now next one, what you have to do is, at the this is the front side of the main plate. At the front side of the main plate we have to provide the front gasket, right? Actually this gasket is called backward gasket. What we will do is, we'll reverse the direction again and again alternately to make the front gasket and backward gasket. This is actually backward gasket. We have to make the front gasket. So what we'll do is, we can make a copy of that one and that can be rotated. So provide green check to that one. Now we can make a copy of that one by control. We have made a copy of this one. Now we can rotate. That can be rotated from move component and rotate component. Okay, this is rotated, green check. Now this one will be working as front gasket and this is as the backward gasket, right? So how we are arranging, first one will be the end plate, then main plate, and here it will be the front gasket. Front and end will be arranged alternately. Okay, right. So we are arranging this one right. Now again met. Okay, arrange the holes of this one together. One constraint is met, two more constraints are required to be met. So this one and that one will be parallel. Done. Now the gap in between these two surfaces should be 0. Select that faces, gap is met, so done. This is complete, right? Okay, now the very important part of this one, what you have to do is, now we know that this thickness of these all parts are 20 millimeter. What we have to do is, alternately we have to arrange all these things. What we'll do is, we'll set this one using some specific command at a specific distance away. What we'll do is, we'll use the command like linear component pattern. We'll use linear component of pattern to set all these things in a specific way at a specific distance away. So linear component pattern. Now what you have to do is, you have to select the direction. So direction can be set from here and from the any specific line. It will be moving in the front direction. Now it is asking to select the component to be patterned. So we want this one to be patterned. So select that one, right? Now it is asking how many distance away and how many numbers to be patterned. So what we have planned is, as each one is actually having 20 millimeter, so alternately this front and back one will be arranged. So what we have to do is, at 80 millimeter away we have to arrange all these things. Change the distance from 50 to 80, and instead of 1 it will be, let's make it 10 numbers. 10 numbers of these gaskets we are arranging, right? Done. Okay, check. This one we can move it little away. Okay, done. All these 10 numbers are actually 80 millimeter away, and all these are actually front type of gasket. Okay, done. Next one what you have to do is, this main plate you have to put inside these gaskets. Main plate already we have put, that to be arranged again inside these gaskets. So again we will follow the same trend or same method, that is linear component pattern. And first of all you have to select the direction. You can select the direction like any specific line. This is the direction, this is going backward direction, so we can change it from here. Now it is in the forward direction. Now as this one should be maintained at 40 millimeter away, we can change the direction or distance also. Now let's the distance here, the distance will be 40 millimeter, and in between it will be 20 numbers, right? So we can change the numbers. Okay, now the thing is, component to be pattern that should be selected. We want to make this pattern, right? It is done. See, 20 numbers have been arranged in front direction. Done, right? Now we can see another thing, like front gasket is provided. Now we want to provide the backward gasket also, right? This is a backward gasket that we provided. Inside these gaps, you can see here some gaps are provided. Inside these gaps, that backward gasket should be provided. So we can drag it here for better assembly. You can drag it here, right? And this one also you can move it little away. Okay, this is done, right? Okay, done. Next one, we have to assemble this one. So we'll start met. Now the holes to be met together. Select the hole, and this hole also is met. So one constraint is met, two more constraints are required. Now next constraint is this to be parallel with this face. Second constraint is also met. Now the third one, that is their faces in between should be having zero distance. Select that faces. Done. So all the three constraints have been met. It is done, right? This is the actually backward type gasket. Now that one should be arranged inside these vacant locations, again by using the previous method, that is by using linear component pattern. We can put all these things in the vacant locations. So linear component pattern. Now we have to select the direction. You can select any specific line, it will go in this direction, okay? And also the object to be pattern. So select that object. Now how many numbers and how much distance away? Actually in this case we want to put these things at 80 millimeter away, and the numbers will be 10. You can decrease the numbers. Now you can see whether 10 numbers or 8 numbers. We can check it accordingly. Let's see, suppose if I giving it 9, it is not done, right? You can see this is a gap, so we have to increase by 1, 10 numbers. Done. So all the gaskets have been applied properly, right? So one thing is remaining, we have to apply the front gasket. Two gaskets cannot be applied by the same time. This is the backward gasket, the front gasket cannot be applied over here. So what can you do is, at this location we can put another main plate, then only we can apply the front gasket. Okay, so we can drag one of the main plates by control. We've taken this main plate. Now we can arrange it by met. You can select that holes. Selected. One constraint is made, two more constraints are required. So select the side surfaces. These are parallel. Now one is required, that is the distance between them should be 0. That means they should be meeting together. The gap between them is 0. So it is done. Now the last one, this is the front plate, or this is the main plate. At the front side you have to apply the front gasket, right? You can bring it here. Okay, done. Now we have to assemble it. So what can you do is, again select that holes, first constraint is met, two more constraints are required. Select this one and that one. Done. Now the third one, that is two faces should be coinciding or meeting together. Select that faces. Done. All the constraints are met. So this is our assembly, right? So green check, done. Now I want to do one thing more, like for better understanding how the water particles or fluid particles, hot water and cold water will be passing through these plates. To show that one, you can do one thing. You can show the basics of this flow simulation using SolidWorks, in which you can understand the passage of water throughout this plate type heat exchanger. Okay, so we're starting this one little bit. We will not do analysis because it is already done in another video. Start flow simulation, and we want to provide the lids at the front gasket. Create lids. We have to select the surfaces for providing the lids. You can select this surface. So lids have already been provided. Green check. You can see 4 lids have been provided, right? Okay, done. Now next one, we want to do one thing, like our aim is to show the passage of different fluids, maybe water at high temperature and water at low temperature, how it will be passing throughout this one, that to be shown, right? So for better visual, what can we do is we can change the transparency of this assembly, right? So we'll do it. Better to select this from the geometry and change the transparency. Now you can see all the parts of this assembly are completely transparent. We can view the passage of these different types of fluids throughout this heat exchanger. For that, what we have to do is we have to start flow simulation. First of all, we'll save it. You can save it by the name of assembly 12. Next, we're starting with wizard. By default project, we're selecting the default project 1, and we're considering SI system and temperature, degree centigrade we're considering. Next, it is an internal analysis and heat conduction in solids we're considering. At the same time, gravity will be also working, and it will be in the y direction, minus 9.81 meter per second square, and in z direction it will be 0. Next, liquids, it will be water. That means we are providing water at different temperatures through different entries. And solids will be considering like metals, will be copper and other metals like these gaskets we can provide later on. We are considering default outer wall thermal conditions and roughness. Next, considering the temperature as 20.05 degrees centigrade. Finish, right? Okay, now the most important part, we have to show the fluid, that is fluid subdomains. It is recognizing the volume. You can see the computational domain. We can make it hidden. We can show the fluid domains because 2 different types of fluids will be passing through this plate heat exchanger. So fluid subdomains, insert fluid subdomain. Let's provide hot water at 100 degrees centigrade. Will be passing through this end, right? We have to select that location. So you can see this is the domain for hot water. So what I told that it is trying to make alternate location for hot and cold region. So what will happen, you can see in a better way from here. Like hot water will be passing through this way, and while passing through this way it will be having some kind of diversion. It will go across this way, and again it is coming down. Similarly, it is going this way, by the same time it is going across this one and it is coming down. So this is the path of hot water, right? This is the inlet of hot water and this is the outlet. So while going in the forward direction, it is going in the this direction also, right? This is the fluid domain for the hot water. Similarly, some gaps you can see here. This is the fluid domain for cold water. We'll show that one also. Again, fluid subdomain, insert fluid subdomain, and in that case water will be having lower temperature, so we can select the temperature maybe at 10 degrees centigrade. It will be passing through the lower part of this one. You can select the lower part. Like it will be passing from here, right? So this is the subdomain for the cold water. So alternately, this one is for hot water and this is for cold water, right? You can see. Okay, analysis of this one has already been made in another video, and today's task was to show how the different parts are assembled and how it works actually. That's why I have shown this one. I am finishing this assembly today here itself. If you like this video, please subscribe and share, and if you have any kind of doubts, please write to me. Thank you so much for watching this video. Thank you again. Bye.